Hello everyone, my name is Krishna from EC department. Today we are going to discuss about properties of Fourier transform, duality property of DFT. Duality property is one of the most important properties of DFT. It states that if x of n has a Fourier transform, capital X of k, then if we consider a new function, capital X of n, it will have a Fourier transform x of capital N minus k, which is a function of frequency. It can be mathematically represented as if x of n has a Fourier transform capital X of k, then capital X of n has a Fourier transform capital N into x of minus k to the suffix capital N. It is also equivalent to capital N into x of capital N minus k. Let us understand more about duality. In Fourier transform, the synthesis and analysis equations are similar. To move from one domain to another, the known values are multiplied with basis functions. The fact that DFT and inverse DFT uses the same mathematical approach is remarkable, even though we arrived in a completely different way at both the procedures. A complex DFT expresses both time and frequency domains as a complex signals of endpoints each, which makes the two domains completely symmetrical. The symmetry between the time and frequency domain of a signal is called duality. The duality principle is widely used in solving various mathematical equations in DFT. Let us take an example. Consider a single point in frequency domain which corresponds to a sinusoid in the time domain. By duality principle, the inverse is also true. A single point in time domain which corresponds to a sinusoid in frequency domain is also valid. Also, if we consider convolution of a signal in time domain, it corresponds to a multiplication in frequency domain. According to duality principle, the opposite, that is, convolution of same signal in frequency domain corresponds to multiplication in time domain. Let us understand more with the help of a picture. Let us consider the figures D, E and F. Now, here we can see that they show an impulse at sample number 4 in time domain. It results in 4 cycles of cosine wave in the real part of the frequency spectrum and 4 cycles of negative sine wave in the imaginary part. An impulse at a sample number 4 in real part of frequency spectrum results in 4 cycles of cosine wave in the time domain. Likewise, an impulse at a sample number 4 in imaginary part of frequency spectrum results in 4 cycles of a negative sine wave being added to the time domain wave. By this, we can get a clear idea of duality principle. Let us try to derive the proof for this duality principle. Let us consider the following discrete Fourier transform. Capital X of k equal to sigma n equal to 0 to capital N minus 1 x of n into e power minus j 2 pi kn divided by capital N. Let us replace k by n and n by k. Then we will have capital X of n equal to sigma k equal to 0 capital N minus 1 x of k into e power minus j 2 pi n k divided by capital N. We know that e power minus j 2 pi n into capital N divided by capital N equal to 1, and using that property we can multiply the exponential term to the capital X of k, and we have capital X of n equal to sigma x of k into e power minus j 2 pi n k divided by capital N into e power minus j 2 pi n into capital N divided by capital N. That implies capital X of n equal to sigma x of k into e power minus j 2 pi k minus capital N into small n divided by capital N. It can be considered as equation 1. From discrete Fourier transform properties, we already know that x of n equal to 1 by capital N sigma capital X of k into e power minus j 2 pi kn divided by capital N. Let us consider this as equation 2. Now, by comparing equation 1 and equation 2, we get capital X of n equal to capital N into x of capital N minus k. The above equation can be written as capital X of n equal to capital N into x of minus k to the suffix capital N. So, by using this theorem, we can find the finite duration sequence if we know the DFT. Now, let us try to understand duality more with the help of a MATLAB program. Here, I have taken a variable t which represents the time. It is equal to linspace 1, 10, 10, which basically means that I have taken values from 1 to 10 with 10 points linearly. Now, I have considered a function y equal to sin t, which is our signal. Here I want a 10-point DFT, so I have taken n is equal to 10. Now, I have taken another variable y2 and I have defined it as y2 equal to zeros of 1 comma capital N. It basically means that I have taken an array y2 and filled it with zeros from 1 to n. Now, I have taken another loop. For I equal to 1 is to 1 is to 9, y2 of I equal to y of I plus 1. Basically what I did is, I have taken values from 1 to 9 with an interval of 1. So I would be taking values like 1, 2, 3, 4, 5, 6 and so on till 9. And now these I values are substituted in the following formula so that we get an equation. Now I have assigned them respectively to the index numbers I in a y2, which are basically zeros. Now after that I have assigned y1 value to the y2 of n. Now I have flipped this y2 using the function fliplr and assigned it to y3. And then again I have multiplied this y3 with capital N and assigned it to y2. Now basically what I did is, I have tried to create the formula of duality which we have studied earlier, which is capital N into x of k minus n. Now capital Y equal to FFT of small y comma capital N. FFT is a function which is used to create a fast Fourier transform. Now I have wanted a n-point fast Fourier transform. So I have used the attributes small y comma capital N. Now capital Y2 is equal to FFT of capital Y comma capital N. Now this Y2 is again the fast Fourier transform of capital Y. Now again I have taken several subplots and then I have given appropriate titles to them so that they will all come in the same graph. STM is nothing but it is a function used to plot Fourier transforms. Here we can see the result. First we have an input signal and then we have the fast Fourier transform of the input signal and then we have the fast Fourier transform of y using FFT function and another same function but using the duality property. We can see that FFT of y using FFT function and using duality property are both the same. So we can say that no matter how we approach, the values will be the same in duality property. I have taken the following books into consideration and I have referred them in making this following video. I hope you have learned something new in this video and thank you very much.